Hey, Andre, that thing doesn't have a Hemi.
No, that thing's got a Hemi.
Do you remember those commercials from back in the day when there was this dude who was so impressed with the Hemi engine that he brought a dragster?
Yes, and the truck won.
Yes.
The Ram 15, Dodge Ram back then.
Well, let's play that commercial so you guys can remember it, because we are going to be talking about a trend in the business that no longer has us having as much displacement, as many cylinders, but the cylinders are replaced by forced inductions and turbos.
And sometimes superchargers, but
Yes,
mostly turbos.
Mostly turbos.
Yes.
Well, as you can tell, we're going to be talking, but you know what? Let's just go and play that commercial first.
Hey, that thing got a Hemi?
Yeah.
Sweet.
The all-new Dodge Ram Heavy Duty.
Did you mean the Charger? Because you know that's got a Hemi too.
You're right.
Now with a 345 horsepower, 5.7-liter Hemi Magnum. Ram Heavy Duty. Enough muscle to grab Motor Trend's 2003 Truck of the Year award.
So, Andre, the new Ram 1500 doesn't have a Hemi.
Not anymore. But you know what we do have on this episode of TFL Talking Trucks podcast?
A Hurricane?
Well, even better.
Okay.
We have an engineer, a chief engineer from Stellantis and Ram and Dodge vehicles who worked not just on the current twin turbocharged Hurricane engine, but also was one of the originals to work on the 5.7 Hemi V8 engines.
Yeah, and the reason he's on the show is because, of course, we toasted the 1500
Hurricane
on the TFL toaster.
Yep.
And there were some small issues. Well, I think they weren't small, but I'm sure Ram thinks they were small. Anyway, that's why he's going to talk about that. But before we get to what happened on the toaster, let's talk about this trend that's happening, well, for the last 10 years now in the truck business, right? And I think it'd be fair to say that Ford started it.
Yeah, this was 2011 actually, which is what, 13 years ago now?
Yeah.
Maybe more?
When they introduced the six-cylinder EcoBoost.
Yeah, and that was kind of...
Two EcoBoosts, a 2.7 and a 3.5.
Well, 3.5 was first.
Yes.
Right? So 3.5, and Ford really went there, right, back in 2011. And they've kept their V8, their 5-liter Coyote is still here with us even to this day.
But the take rate on that thing is pretty small.
Yeah. Now twin turbocharging, and it was kind of a huge decision back then, but a lot of manufacturers have since kind of went that way. And I think really it was kind of partially controlled by regulations, right? Fuel efficiencies, emission standards. But what it did give us is more torque, right? A lot more torque and maybe even more horsepower in some cases.
And a lot less glorious turbo-free, naturally aspirated V8 rumble.
Yes, a lot less rumble.
I think that's what people miss the most. But let's talk about not just Ford, who introduced it. So Ford started with a 3.5, then it went with the 2.7. Back then, they also had a diesel, which kind of went away. And they kept the Coyote, the 5-liter. But that probably seems to have found a better home in the new Mustang than it has in the F-150. But the other manufacturers followed suit. So you know this. What did Chevy do?
Well, Chevy, they still have their V8s.
They have a 5.3 and a 6.2, but they also have...
Yes, 3-liter turbo diesel.
Exactly.
Which is, I think, one of the best engines out there currently. It's the 3-liter Duramax, straight 6, right? And, of course, Ram has been... Hemi has lived...
Wait. Did you forget about an engine that Chevy has?
Oh, 2.7 in my truck.
That's right.
That's later.
No. In
the Silverado, too.
Yeah, they have a 4-cylinder turbo.
Yes. You know how they introduced it?
How?
They invited TFL Truck to GM Proving Grounds in Milford, Michigan.
Hey, podcast listeners and TFL Talk viewers. I wanted to take a minute to talk to you about a quick and simple way to sell your car or truck with the help of our new partner, HighRoad. With HighRoad's online portal, you enter your vehicle's VIN number or plate, mileage, and zip code, and you'll get competing offers from several qualified dealers in your area within seconds. You pick the best deal offered and follow through with the dealer to sell your vehicle. No more managing scammy emails from buyers on Craigslist or Facebook Marketplace. No more time wasted on no-show buyers. No bait and switch with a "will you take a check" excuse from sketchy buyers. Now keep in mind, These offers will be for trade-in values of your vehicle. If you want to go through the hassle of getting more for your vehicle, that's up to you. But if you want to sell your vehicle hassle-free and fast, go to tfltruck.com and click Sell Your Truck in the navigation menu. Or click on the High Road ad at the bottom of the website if you're on mobile, or click on the column if you're on a desktop. High Road makes it easy, and we like easy.
Right, and they invited a few journalists. I was fortunate enough to go. And we walked out there, and there were 3 trucks parked. I think there were 3 trucks parked in this parking lot next to the test track. And they said, we're not going to tell you which engine is under the hood, but we want you guys all to drive these trucks around for a few minutes, and you tell us what you feel. And I jumped in there, and I did not hear a V8 rumble. And the power, there was a lot of torque. I could feel a lot of torque. And I was like, is it possible? Because I had a 2-liter turbo. I was like, is it possible they put a 2-liter turbo in this big Silverado truck? And it was not a 2-liter.
Yeah,
It was a 2.7.
2.7, yeah, and it's actually a really good engine because, having driven that truck, what it does is it makes the truck a lot lighter. So it feels like it's more kind of
It's not
urban,
happy.
yeah, more urban ready. It feels just lighter on its toes. It feels like you can kind of, whip it around corners, like you can park it easier. I'm not saying you can, but that's what it feels like with the 5.3 and the 6.2 V8s. Those are big, heavy, powerful engines that are great for towing, but if you just want a truck to zip around town, I love that little 4-cylinder. And then, of course, the 3-liter diesel. I'm not going to say it's a baby Duramax. Let's call it the adolescent Duramax.
A smaller one, teenager.
Right. The adolescent.
Well, not a teenager. He's in college.
And that's also a glorious engine if you're a fan of diesel.
is.
But you kind of skipped over the other big truck brand because they did the same thing. And I'm, of course, talking about Toyota. What did they do with the Tundra and the Tacoma?
So for 2022, the model year, the Tundra went all turbochargers all the time.
And hybrid.
And hybrid even a little bit later in 2023 as well. So first there was Ford. GM was kind of there as well, 2021. Then Toyota went there with, really, their engine is a 3.4 liter, slightly smaller than the Ford's, right, as far as displacement.
And they're replacing all of them.
Some of them. They're replacing 100,000 of them because of a manufacturing defect, let's say.
Yeah, that does not fill, I'm sure, buyers with confidence about the, let's call it, the reliability of a 6-cylinder turbocharged 3-liter, 3.5, right?
3.4.
3.4 versus that of a traditional. What was the first one? It was a V8. It was a 5. I always get the Nissan mixed up with the Toyota. Is it 5.7 or was that the Nissan?
So the endurance engine is 5.6.
Okay, so it's 5.6,
Yeah.
and Nissan had the 5.7 before the Titan died.
No, the Nissan had a 5.6.
They both had a 5.6?
And the Toyota had a 5.7.
Okay, right.
Sorry about
See,
that.
I
I
always
thought
get-
you were talking about Nissan.
I always get those mixed up. See, it's easier to even I got you mixed up. Anyway, that old 5.7 in the Toyota was bulletproof. It was known to go easily.
But not initially. And this is what I want to talk to Alan about, right?
Okay.
Alan from Ram Engineering. Because whenever something new, happens, like the 5.7 iForce for Toyota, and maybe even the Hemi, I want to talk to Alan about this. They initially had some issues with their 5.7. Toyota did, right, when it first came out.
Yeah, but we did a video of a 1,000,000-miler.
Uh-huh.
Yeah, I mean, they seem to have sorted those issues out. And then for a Tundra to go 1,000,000 miles, that's pretty darn impressive. Remember, they bought it back from the owner. And
That
gave
was
them
a
new Tundra.
different V8. That was a 4.7, I believe.
Oh, that was
the
previous
smaller,
one. That was
the
a smaller
V8.
V8.
Yeah.
Okay, all right.
So
Still-
not everything
still-
is perfect.
Still V8 and still 1,000,000 miles, Andre. So now, of course, we've come to the Tacoma, which has also gone from a 6-cylinder naturally aspirated to a 4-cylinder turbo. And I think a lot of listeners and a lot of people out there just aren't happy with this trend. And I see why, right? Because naturally aspirated straight 6s or naturally aspirated V8s are just some of the best engineering designed, technically proficient powertrains you can get. And now you're going into the realm of like maybe 4 years ago, every German entry-level car went to a 2-liter turbo. Like everyone. Mercedes.
No matter what it is.
No matter
yes.
what. They all went 2-liter turbo. And now you've got a truck with basically that same engine, and it just seems wrong.
Yeah, and it's also the character of the thing, right? The character changes. Like you said, there's no longer that guttural kind of deep sound of a V8. Turbochargers are like blenders, right? So basically, when it's exhaling, there's a turbocharger there on the exhaust system, and it provides boost for the engine, but it also kind of blends the sound, right? So the sound becomes a little bit more blended, not as pronounced. And so I've owned a 2023 Colorado.
Here's my analogy.
What?
Do you like chocolate sundaes?
Yes, love them.
So you get vanilla ice cream, put chocolate on it?
Yes.
Now, what if I said no chocolate, but instead kombucha?
Kombucha Sunday?
Yes. Right? You wouldn't be all that happy, would you? You don't want that stuff. First of all, I don't even know what kombucha is.
It's healthy.
Yes, I know. Well, it's fuel efficient. My whole life, I've been, eating my sundaes with chocolate on it.
Yeah.
And I've learned to love that. But now we're putting kombucha on your ice cream, and somehow it just feels wrong.
Maybe I think you just started a new trend, Roman. Kombucha ice cream.
Yeah, whoever, feel free to run with it. Give us 10% of the profits and 0% of the loss.
Kombucha ice cream. Please come and get it.
The kombucha hut. What would you do instead of strawberry sauce? You know that strawberry sauce?
Brussels sprouts.
Oh, God.
No.
Brussels sprouts. Yeah, that. No, you can keep all that idea.
So-
All right. So now we have the only brand that kind of stuck with the 6, and that is Nissan. So Nissan has soldiered along.
Well, the Titan is no more.
Right, that's gone. But with the Frontier, we still have the V6.
It is. Yeah.
And of course, we also have the V6 in the
Honda.
In the Honda.
And the Jeep.
And the Jeep.
And the Jeep is still
The venerable
V6
Pentastar.
only.
Yeah. But that's, those are hangers on, I think. Those are kind of becoming outliers as opposed to the trend, which may or may not be your friend.
And so here's what happened with trucks and V6 engines as well. If you look at the older mid-sized GM trucks, if you look at Nissan with V6, and even Honda and Jeep, is they rev high. Remember, you and I were in the Jeep Gladiator, and we were towing up the I-Gauntlet.
It's not a pleasant experience.
And you're at 6,000 RPM, and it just goes...
And the Pentastar, I think, will be proven in the long run to be one of the most venerable, one of the most
they've built
reliable...
millions of them.
Yeah. I'm going to say Stellantis engines, but really it probably goes back beyond
Chrysler.
FCA. Yeah, it goes back to Chrysler. But yeah, towing with it is not pleasant. It feels like it's going to pop a cylinder, a valve. Or you're going to blow something out of the hood.
But it never does.
It never does. It just keeps trudging along. But now let's go to why we're going to be speaking with this engineer. So we've got this picture of the new Hurricane. So tell me about the Hurricane so we can kind of tell them the story of the Hurricane.
So when we first learned about it a couple of years back, right?
It's a good name.
It's first of all, good name.
Good
Hurricane.
name.
Powerful name. It's a straight 6 in this case.
Not as good as Go Devil. That was in an original Jeep.
Yeah.
Had a Go Devil.
Yeah.
That was a 4-cylinder.
Yeah.
But what a great name.
Or the Devil engines. Yeah.
Go Devil, yeah. Especially if you're going to war. Man, what a great name.
And then the straight 6 orientation, right?
Yeah.
Semi-trucks use straight 6 diesels, really powerful engines.
And as you know, Andre, the 6 is the smoothest of all of the...
And let's just look at the Germans just for a second.
Yeah.
Straight 6 BMW engines.
BMW has been known for doing straight 6.
Yeah.
It's just so balanced and so smooth. Unlike, if the V8 is heavy metal, then the straight 6 is jazz.
Yeah, and beautiful song.
Yeah.
Also, one of the best high-performance engines is a Toyota 2JZ, right? It's the 3-liter straight 6 from the Supra that's been, tuned and makes, 2 million horsepower.
Can I give you a story about that? So I was at Cars and Coffee with my friend James this weekend, and he just purchased on Bring a Trailer a brand new to him Toyota Supra.
What year? What generation?
4th gen, the one you want.
Okay.
Yeah, with the turbo. So it was turbocharged. Unfortunately, it was automatic, which you can swap that out.
Okay,
but people
sure.
want manuals now.
Okay.
But still, I think he paid over $50K for it. Those things.
Wow.
Yeah. Anyway,
Does he have it yet in his possession?
Yeah.
He has it.
Oh yeah.
I need to call James.
Oh yeah, it's beautiful. It's
Oh my gosh, what color?
It's this blue, kind of this
Okay.
metallic blue. Anyway, so we're at Cars and Coffee with it, and he's out talking to somebody else, and I'm kind of standing by, and I see this guy, and I take it as his girlfriend walk by, and she says, "Man, I want that car. That is my dream car." And the guy looks at her and says, "What would you do with it?" And she said, "I drive the out of it.
She said this?
Yeah, I drive the F word out of it.
Okay.
And I thought, that is terrific. We should make a T-shirt out of that. So we
Okay.
have, Andre. So
Okay.
if you want a T-shirt with...
TFLstuff.com.
Yeah, go to TFLstuff.com
okay.
and drive the you know what out of it. And we didn't
So-
use the F word. Don't worry.
No.
We're family friendly.
We're clean.
Yeah.
And so when I heard about the Hurricane, straight six, twin turbocharged, 3-liter, I'm like, okay, it's hitting all the good parts. Straight six, displacement sounds right. Not one, but 2 turbos. How bad could it be, right? And then finally we drive it. First it was a Grand Wagoneer.
Yeah, so I drove it in the Grand Wagoneer. And I thought, especially the Grand Wagoneer being such a big and heavy vehicle, right? Basically, it's a Silverado. I'm sorry, my brain is fried. Basically, it's a Ram 1500 with
a cabin.
with a cab, yeah,
With a wagon.
yeah, and so it weighs a lot. Remember, did we have it in Chicago? Or was that
We did, yeah.
It's
We
a
had
it's a
a
big,
loaner.
Yeah, it's a big beast. It's expensive, and I thought it was just fine. I did a 0 to 60 on it. I forget what that time was, but it was plenty fine for something that is going to haul around you and your family. And I was a little concerned because I wasn't sure that when you start adding weight like a trailer and 10,000 pounds worth of, in this case, or 7,000 pounds in this case, of skid steer, it was going to be powerful enough. So while it did well in the Wagoneer, I wasn't sure how it would do it. I think there was a towing loop with a Airstream, if I remember right, but you can't really tell by going around like a 5-mile course.
Yeah.
You just I mean, a mid-sized truck will pull that. So it wasn't until we actually got the thing on the toaster that we really figured out how powerful this is. And you want to tell them what happened on the toaster? So tell them what the toaster is first, and then we'll tell them what happened on the toaster.
So the toaster, we really can only do this like during the summer months, the hottest months, probably June, July, August, September.
The TFL toaster.
Yeah, TFL toaster test. And it's an 8-mile run from Boulder, Colorado, up towards Gold Hill, Colorado.
And it's very steep.
And very windy.
Yes.
It's a very windy mountain road, which means it's very, very slow. So average speed is between 20 and 25 miles per hour. And it takes a long time to drive it, right?
Yeah.
8 miles at that speed.
Yeah, and we tried to pick the hottest day of the week, if possible, to do it. If
So
not,
usually in the
month.
90s, maybe 100 degrees.
Yes, and then part of it is paved, part of it isn't paved. And what happened when we took the Silverado up the toaster?
This was several years ago. Silverado 1500 with the big 6.2 and a 10-speed. The transmission got way too hot, and the truck made me stop by giving me a message. I think it was like, too hot, please pull over to cool down, something like this. We're like, whoa. And we weren't even at maximum capacity then.
Yeah.
So we thought to ourselves, wow, this is not out of the ordinary. We were towing about 7,000 or 8,000 pounds. We were going up this road, and people live there. It's a neighborhood, right? So we're like, well, how will other trucks do at this test?
Yeah, it's an extreme towing test, and we've got certain criteria that the truck has to meet, and they're very straightforward. Basically, if it throws a warning light or if it throws an error message, then it fails the toaster. So the Silverado failed the toaster. All right, so fast forward to not that long ago with the F-150. What happened when you took the F-150 up the toaster?
So this was a Tremor. So this is an off-road model of the F-150, and it had, I think, a 5-liter.
Yeah, you and Case
This was a V8,
Yeah.
not a turbocharged engine.
And we're towing, what, 10,000 pounds, right?
Yeah,
So
now,
skid steer plus...
now we're towing just over 10,000 pounds. So we're pushing this truck to its limit now, to its maximum towing capacity. And the truck pulled power. It didn't really have, and 2 error messages. So the error messages was coolant too hot, I believe. Coolant, not transmission in this case, but the engine coolant.
So that's a fail.
And also, when it pulled power, it was obvious. I was stepping on the accelerator pedal, and there was nothing happening. We were still moving forward, we were still driving, but there was no acceleration, no kick down on the transmission, and very slow going.
So now go back like 3 weeks, and Andre and I are taking the new 1500 Hurricane straight 6 twin turbo up the toaster. Same load, 10,000 pounds skid steer with trailer, 10,000 trailers 3, skid steer 7.
Yeah.
And we made it all. Well, why don't you tell them what happened? I won't spoil the surprise.
Yeah, so never pulled power.
Nope.
So at first I was thinking, oh, okay, something similar may happen to the F-150.
And we're watching the transmission temperature, and it's getting
and it's
hotter
actually
and hotter.
giving us good information,
Yeah.
right? All digital.
Yeah, some of the trucks don't even give you the transmission temperature.
Or in a digital way,
Yeah.
right? It's numeric way, like how hot is it actually is versus like a little bar graph.
Yeah, well, now you're in green, now you're in green, and now you're in red.
Yeah.
That's not very helpful.
And then at the very top, dude,
When we finished
the run, I put it in park.
Yep.
And bam, low oil pressure light comes on.
So we called it a fail, even though
it happened at the very, very top.
we were done. It still threw a code, and so we published a video, and then I don't want to spoil what the engineer is going to say because that's really why we're talking to him on this podcast.
Because we have questions. And you guys have questions too.
So shall we have a chat with the chief engineer?
But there's one more thing.
Okay.
I'm also going to ask Alan about the Ike. I took it on the Ike Gauntlet test the week after.
Yes, and we had some issues with
going down the hill as far
braking.
as grade shifting of the transmission and slowing us down on the way down the mountain. So and that's one of the complaints I hear about small displacement engines, right?
They don't have these big pistons.
Yeah.
Where when you're going down and then you put it in second, we don't put it in second. We just keep it in
tow haul
drive.
mode.
Yeah, tow haul mode. So what should be happening is the pressure should be helping to slow down the truck. And why don't you explain to them how we score the Ike? So people, in case you haven't ever watched an Ike video, let's kind of refresh people on that.
On the way down, we really want to have the truck work for itself instead of the driver downshifting the transmission.
Yeah, it's a test of the truck, not of the driver. We could control the load, but so can anybody else. It's really can the truck do it and not Andre.
Yeah, and we count brake applications, right, between 50 and 60 miles an hour on the way down. The fewer brake applications, the better, and the better the truck does.
So the way you do that is every time the truck exceeds 60 miles an hour, we push the brake and we get it back down to 50 miles an hour because obviously the faster it goes, the less control you have of your towing load. Yeah. And then every time we do that, it's one brake application. And the more times we have to do that, the worse the truck does in terms of its score because what it's telling us is that it's not sufficiently slowing down whenever we're towing going down a very steep hill.
And the Hurricane didn't do that well. So I want to ask Alan about this on the downhill. It did wonderful on the way up the hill because it does have a lot of power and it's so smooth. But now we have questions about oil. We have questions about development and testing, durability of these engines. So should we talk to Alan now?
Yeah, I want to thank Rick, who's the head of PR over at Stellantis, for helping.
And also Nick Kappa.
And Nick Kappa, who's running trucks now, for helping us do this. They have been just incredible to work with. Every time, we have some kind of an issue, they provide us with the matter expert to explain. And I think that's very valuable because, there's so many forums out there and there's so many different people with so many different views. And it's really nice to talk to the source, and especially nice to talk to somebody who has actually done both the Hemi and now the Hurricane.
Mm-hmm.
So it'll be really interesting to get kind of his take on the difference, and are we moving forward or backward in terms of truck development.
Yeah, I cannot wait. Let's bring Alan on. Hi, Alan. Thanks for making the time to be with us today.
Thanks, Andre. Thanks for the opportunity. I really appreciate it. I think you guys do a great job, and I wanted to be able to contribute to some of the reviews that you've done on our products.
Well, thanks. I see your background right there on our video conference is the event in Texas when you guys launched the new 2025 Ram 1500.
That's right. It was down in Austin, and we had the opportunity of meeting yourself and a lot of other journalists to share with them our products and the engine launching into this vehicle, right? Our Hurricane 6 in two versions, right? We got a standard output and a high output. They're both out there and available for customers now.
Yeah, I was there. I spoke to you a little bit when I was there. So that was a great event. It included off-roading too and pulling trailers. We've done a few videos from that event, so that was pretty amazing. I wanted to get your perspective because we've had one of your trucks. This was a tradesman, right? So this was a standard output Hurricane 3-liter twin turbo, and it's kind of a work truck configuration. And we put it through the ringer. I drove it to Denver from Detroit. I So we did a road trip in it. We pulled trailers. We put it on a TFL toaster test, a gauntlet test, and I believe we also did a efficiency run on it as well. That was part of the road trip. And before we get to some of the, kind of your feedback on some of the testing we've done, I wanted to hear a little bit more about your background, because you've been with Stellantis FCA Chrysler for a long
long
time.
time. That's right. I'm an old guy. So I've been doing, yeah,
Can you tell
yeah,
us a
yeah.
little bit about it?
Sure. I've been 35 years now. I've had a career with, it's basically 5 different companies and all the different versions of it. And I started out doing like simulation and analysis of engines, and grew my career from understanding the physics of engines to figuring out how do you design engines, how you design components for engines, then into leadership roles where I was chief engineers for programs or engineering manager for programs. And today I'm the director for our what we call propulsion component product release center. So I'm responsible for the hardware engineers for all the engines and all the batteries that we produce here in North America. And it's been a great career. I really have been fortunate to have worked on a number of programs that were critical and important to the company. And one of the key things that really stands out for me is I get to lay claim to being the very first engineer that worked on the current generation Hemi engine, and it's been a lot of great memories there on that program and the people who worked on it.
Well, yeah, I want to touch on that because I was telling Roman in the beginning of this podcast that I remember watching those viral commercials from over 20 years ago. That thing got a Hemi, and there was a 5.7, right?
That's right.
5.7 liter Hemi, and you were one of the original team members in the late 90s, even.
That's right. We started in the late 90s. It really was myself, another engineer, and 2 designers. We started laying out, let's say, the architecture, the concept of the engine, and provide enough information that we were able to take it forward to get, let's say, the program approved. And then once that happened, we grew the whole team. It's a great team. We were able to have an off-site location dedicated to just the engine, where we were able to have everybody associated with it. So engineering, manufacturing, purchasing, we were all in this little, we call it Retron was the name of the facility. And it was a tight-knit group, great team, and we were able to make a great engine.
So were you involved in various iterations of the engine? Because there's also like the 6.4, there's some others. Tell me a little bit about the family of engines.
Yeah, so we started with 5.7 liter, right? And then the next evolution of it was our cylinder deactivation version, right? We called it multi-displacement system. And I was the technical manager for the engine for that program. And it's kind of like a chief engineer role where figuring out how do you make this so that it is transparent to the customer, right? You don't want to know when the engine's switching between 4 and 8 cylinder modes because the previous attempt at it was, it failed because of that. It was really obvious. So I told the team, we got to make it transparent. And if we can do that, we'll have a successful product. So we had let's say the multi-displacement version of the engine. From there, we started to grow other iterations of the engine. At that time, I wasn't involved with it, increasing displacement, SRT applications and such. But I did come back around again I was the chief engineer for the Hellcat version, right? The 707 horsepower. I got engaged again and I wasn't able to launch it at that time. I had to go and do another project, but from the concept until we were able to demonstrate that we can make 700 horsepower, because at the time, nobody thought we could. We, worked with team that does vehicle simulations. And at that time, they said, we need 658 horsepower, Alan. And I said, come on, guys, nobody's going to recognize that. Isn't going to get anybody's attention. I said, it's got to start with a 700 horsepower plus. And we did. And that was a target for the whole team. It's like, how do we get there? What do we got to do? So we went through iteration after iteration, had a big shootout on superchargers, and it's a lot of fun.
Well, yeah, I mean, that was amazing. I remember I think it was 2015 Dodge Challenger Hellcat, and we actually owned one at TFL Studios, and it was just because it was warranted, it was mass produced, right? I mean, it had a lot of really, really impressive. Of course, power numbers were really impressive, but
for that day, Yeah. Now, right? We just launched the 1,025 horsepower version. And again, I was able to be involved with the team because my engineers were working on the product. There's a different chief for the program. He did a great job on that. But I was able to reconnect again with the Hemi program. And I mean, gosh, we would never expected to be over 1,000 horsepower when we were first laying out the engine. So it's been quite a journey.
Is that the Elephant?
Hellcat.
Oh, the Hellcat version? Okay.
Yeah, it's the Demon. I'm sorry. It's the Demon 170. So
Yeah. Okay. Yeah.
my bad.
Yeah. No, sorry. A lot of cool names, by the way. So the Hemi engine replaced the Magnum, the Magnum series of engines. And now you have the Hurricane, which is also quite a cool name. So whoever's doing your naming for your engines is doing a really good job.
It's important. It really is to be able to have people associate with the engines. And, Hemi is obviously a brand. And so we were trying to find something that people can associate with what's under the hood. And I think it's important.
So let's transition a little bit more. What makes a truck engine a truck engine? Because it's not quite the same as a Dodge Challenger, let's say, versus a TRX in that way.
Right, for sure. I mean, the challenge with a truck engine over a passenger car engine is that it's got to be able to operate over a wide range of conditions, right? A lot of our customers buy them and they just drive them to and from work or to go get groceries, and they expect it to be quiet, refined, get good fuel economy, and just be reliable, right? Just to do that kind of stuff. But other customers use this as a tool for their employment, right? They might be towing on a daily basis. And so we need to be able to make sure that it's going to be durable for them and that it's going to be able to provide, good fuel economy for them, because that's cost for their program. And so when we started out with the Hurricane 6, it was recognized it was going to be a truck engine, right? So we said, what are the performance parameters we got to achieve? What kind of durability do we have to achieve? And what kind of characteristics does it have to have? And one of the ones that we really focused on was under heavy load, under towing conditions, the boosted engine. We know that, say, some early efforts on boosted engines didn't always provide good fuel economy under towing conditions. So we wanted to make sure that that was eliminated. And I think you even made a comment in the toaster review that, wow, fuel economy was good. It was similar to some of the V8s, the naturally aspirated V8s. And that's really what we were trying to achieve was, no degradation in fuel consumption under towing conditions. And so we had to put in place an architecture and features on the engine that allows that to happen.
Yeah.
I can tell you about some of those if you'd like to hear.
Yeah. Let's go there now. Yeah.
Sure. So, and secret sauce here behind getting good fuel consumption under towing conditions is you can't retard spark. If you retard spark, right, you start to waste fuel, waste energy. It goes out the tailpipe and it tends to spiral and get worse and worse, especially under the conditions that you guys are doing, towing up the mountain, right? As you go up, you're going in altitude, you're going slow. Engines and other parts of the vehicle can start to overheat. And we wanted to make sure that that didn't happen. So one of the key characteristics that we have on the engine is the charge air cooling system, right? We use a liquid to air version. So we're not just pumping the air after the turbocharger out to the front and coming back. We have a heat exchanger on the engine. It pumps liquid coolant out to the front and comes back. And why do we do that? Liquid coolant can reject a lot more heat, right? And more importantly, under low speed conditions, it can reject heat. And I think you guys even mentioned that at the beginning of your video. It's like, why is this such a struggle? Because we're going slow up the mountain. And
there's not a lot of air moving, right?
That's right. There's no ram air. So we've got to rely on the main cooling fan. It's able to go across that heat exchanger that has coolant going through it, reject the heat, even under those low speed conditions. And that's why you guys were able to go up there and you didn't have any derating occurring because of it. And I think that sometimes separates us from the competition, is having that feature, that technology, and that capability.
That's really interesting because when you speak about turbocharged engines, right, and you have two turbos, right, on this 3-liter straight six, sometimes when you're talking about like turbo pressures, right, and I'm talking about the audience in general, consumers and enthusiasts of pickup trucks, they usually ask, what is your turbocharger maximum pressure? Is it 20 psi? Is it 22 psi? And the higher the number, some people start to say, oh, wait, you're over boosting it. You're generating a lot of heat, and it's going to be bad, and on and on and on. There's like, I don't know, I don't know. There's a
Well,
lot
you
of kind
do.
of down comments.
Well, there is, but you got to know that and you got to plan for it. And you're right. We've got two versions of the engine, an SO and an HO. The HO boosts to higher pressures and air. Anytime you compress it, it gets hot. So you've got to get rid of that heat. And that's where the liquid to air charge air cooler is able to do that more effectively than what's called an air to air charge air cooler. And when we go to the HO version of the engine, yeah, we've got bigger turbos to boost higher, but we also have bigger heat exchangers on the engine to be able to reject that heat and manage knock in both versions of the engine.
So it's first of all, when you saw me towing a skid steer up a mountain, did you think that we were just crazy, or what was your
No,
first reaction?
no, I mean, I tell you, it's a corner case. It's an extremely aggressive test. I hadn't seen it before on the kinds of roads you guys were driving on, so that's probably the crazy part of it. I mean, loose dirt and having to go into four-wheel drive just to get up the mountain. I think that's the crazy part. So yeah, it's aggressive. It's what we would call a corner case, but it is one that we try to validate against. And so we weren't surprised when you made it all the way up. No problem. What was surprising, and was surprising to you guys as well, is whenever you pulled over and it's like, wait a minute, the low oil pressure light triggered, and what caused that?
Yeah, let's talk about oil a little bit more, and this progression, to what people call thinner oils. And also, yeah, can you tell me, like, from your perspective, we saw, like, obviously, I put it in park, the RPM came down, right? And we're watching the oil pressure gauges, right? And by the way, thank you for all those gauges. We really love information. I think as a pickup truck driver, it's really nice to know all that information. So thank you very much. So talk me a little bit through it, like what was going on, because the oil temps I think were about 250, if I remember correctly.
Yeah, they were in that range. And
Yeah.
and essentially what happens is the temperatures that you encountered are, they're up there, no doubt, and it's a result of the aggressive test. But if you notice that while you're climbing, pressures were higher, right? Because the engine speeds are up, elevated. And then when you pull over, essentially everything is saturated. All the temperatures are to maximum, but the engine speed slows down. And as a result, the pressures that are generated and the pressures that are needed are actually lower as well. So pressure kept coming down, and then all of a sudden it tripped and said, wait a minute, you got low oil pressure. What we did was to look at the video, go back and compare it to our validation tests that we run that produce, let's say, similar conditions. We're not going up a beautiful mountain like you guys are,
Yeah.
unfortunately, but we're artificially creating that by putting a dyno trailer behind the truck and overheating it, pulling over. But what happened was when we compared the results of the test you guys did and what we did, the engine speed that you guys were at was slightly lower at idle than what we were at on our test. And there's a couple of different settings. There's the lowest idle speed, and then there's progressively higher idle speeds if there are, let's say, additional loads on the engine. And in our torture test, the engine speeds were higher, and so we never tripped the low pressure light. Going back and looking into what caused that, it was, I know you're familiar with software, it was a calibration. And in the way the controller operates is we've got two tables. One table says, here's the engine speed and the oil temperature. What oil pressure do we want to operate at? Okay. And then there's an independent table that is for that low pressure light. Same thing, right? Oil temperature, engine speed. And there was a mismatch between the two. And essentially it was down in the corner of that table. And because on our test, the engine speed didn't go as low as what you guys did, we didn't uncover it. So the good news is it was an easy correction. We've already made the change in the software. The vehicles that are being built have that change. The software and the new calibration will be out at the dealerships at the end of the month. And there's no, hardware changes. There was no issues with the hardware. So I think it was, we're, I guess, recognizing the differences there. We've changed our validation tests and requirements that we're going to make sure we go to that minimum engine speed as a result of what you guys did. And we'll make sure that that doesn't happen again in the future.
Well, that's very impressive. First of all, I want to thank you for first of all, for obviously, watching what we're doing and also reacting to it that quickly. I mean, I'm really impressed. So I would like to thank you and your team to to actually, and like you said, it's a corner case, right? But I think a lot of people buy vehicles, especially pickup trucks, on not what they're doing today, but what they might want to do in the future, right?
Mm-hmm.
So the fact is, if you're building a cabin in the mountains and you want to pull a piece of equipment up there, hey, I can do it, right? I can do it with my truck, and I can be confident. And that actually, the oil pressure change was minimal. Wasn't it like 1 psi? I mean, it wasn't
Once you
like
tripped it, once you went over that threshold, then it flags it. So yeah. But what I'll tell you is the distance between that setting and what is needed for the bearings and the other components in the engine operate are miles apart. So actually the thing that needs the most oil pressure is the cam phaser. We have hydraulically operated cam phasers, and to have good control over them, they need to be at a higher pressure. So that's really what sets the minimum threshold. The bearings and other, let's say, mechanical stuff that everybody's familiar with is far below that as well. So the difference between what we had in the software when you drove it and what the needs are for the, let's say, the mechanical bits, they're miles apart. So there was no chance of any kind of damage. There's a lot of cushion.
Yeah.
Obviously, you guys drove the Ike, 2 weeks later or something? Well, no problems with the engine.
We drove it 2 days later.
Okay. So it's still fine. There's no damage to the engine, nothing. Everything's good.
Yeah, I get it. Tell me, explain the cam phaser technology. Is that what is it about? Is that variable valve timing, or can you explain a little bit that concept to me?
I guess, it goes by different names. So variable valve timing. So essentially changing the center line of the cam to optimize for, let's say, if you want smooth idle, you want good fuel economy, or if you want maximum power, right? So we're always having to change the center line of the cams to be able to operate as efficiently and effectively as possible. And the way we do that is there's a device on the front of the camshaft. It has some vanes in it. Those vanes use oil pressure to drive them in one direction or another to change that cam timing. And that technology has been out there for quite a while. We've been using it successfully for a long, long time on just about all of our engines.
I gotcha. Okay. Now let's talk about oil a little bit, right? So a lot of people say, all right, oils are getting thinner. And by the way, after this torture test, would you recommend, I mean, I guess it depends on the oil formulation and, supplier and stuff like that. Would you recommend changing it more frequently? Can you tell me a little bit more about oil?
Oil, yeah. What I'll say is it's been getting better over time, right? And I still do my own oil changes. But what has happened over time is there's a really good relationship between the auto manufacturers and the oil industry, the people that make these products, and the people who make the additives for the oils, because those are key. And over time, there's been a lot of development and learnings, and the quality of the oil has improved. The quality of the additives have improved, right? And oils are much, much better today than they ever were in the past. Majority of oils and what we recommend today are synthetic as well, so they don't break down as fast. The additives last long, and we have inside of our engine controllers an algorithm that monitors how the engine is being used, and it'll tell you when you need to do an oil change, right? It looks at things like, engine speed, engine loads, time, and other factors, and calculates and says, okay, now it's time to change your oil. So you can rely on that to indicate when you need to service your vehicle. Doing it beforehand, you can do it, but it's really not necessary.
So it just depends on that particular vehicle, like you said. So your oil life meter, right,
Mm-hmm.
is precise for the use case that you're driving your
That you're
vehicle.
driving. That's right.
Yeah.
It's looking at how you're using your vehicle and determining, when you need to do an oil change. And contrary to, I think, what a lot of people believe, you know, the worst case for oil life is if you just make a lot of very short trips. And you think, oh, I'm using my engine easily. But if you make short trips that don't allow the engine to warm up, the oil to warm up and allow it to evaporate off the moisture that condenses inside of your engine, that's the worst case scenario. If you just go and drive your car, and even if you drive it hard, it's not really hurting the oils. And they're able to evaporate off the condensate. They'll last, just as long as you need them to. And even whenever we have these kinds of short trips, the monitor's watching that as well.
And you're talking about like a few miles, like 2, 3, 4, 5 miles. That's what
Yeah,
you're talking about.
yeah, that's the worst case because the engine never gets warm. If you live in a climate where you got cold temps, warm temps, especially when it gets cold, you get that condensate that forms on the inside of the engine. It tends to wash down into the oil and over time, builds up. If you run the engine, you get the oil hot enough to burn those off. Oil likes that. It doesn't like being diluted with all that condensate.
I gotta ask you about the dipstick now,
Sure.
because that was a big question from a few months ago. But the new 3-liter does not have a dipstick for the oil.
Right. And that was a decision that we made because, when we look at this investment that people are making in their products, we want to make sure that, we're helping them protect it. And the vast majority of our customers don't use and ever look at their dipsticks, right? So we decided to use a sensor that is always monitoring what is the oil level. And in the event that something unusual happens and it drops low, it's going to let them know. We designed the engine such that within the lifespan of an oil change, you're never going to need to add oil, right? The oil consumption rate is so low, you're never going to have to add oil. So we don't expect people to be looking at oil indicators or dipsticks. And that low oil consumption rate has been enabled by a number of things, but one of the cool ones is the engine itself has what we call a spray bore liner or a plasma spray liner, and it has a very smooth coating on it with little pores in it, and those pores are what absorb the oil and provide the lubrication. But as a result, the oil consumption rate is much lower. So the need to add oil is non-existent on the engine. So we don't expect customers to have to use it. It was never intended. I know some people, and there's enthusiasts that say, I really miss the dipstick. And you're right, there's a small part of the population that does, but the vast majority don't. And we're able to provide the security of knowing your oil is being monitored. And if there's any reason, to raise concern, it'll do that. It'll let people know.
Is it also kind of changes the way you're looking at the overall design of the engine? I mean, routing a dipstick hole or routing a tube, or is that changing in the way you look at it as well, packaging?
I tell you, it's interesting you bring that up because our engines, we would use them in more than one vehicle. And it was always a challenge as you go from, sometimes we'd have a vehicle installed in a north-south application or an east-west application.
I know. Pentastar.
Yes, right, exactly. And so I was the engineering manager for the Pentastar program, and the biggest challenge you have with the oil dipstick is trying to get it into all these different vehicles and manage all the different dipsticks that you need because of packaging reasons, and releasing all those parts. So it's interesting that you stumbled across that or brought that up, but that's really the biggest challenge is you just got to have so many variants for all the different vehicles that you go into, and then you got to calibrate each one of them. It's not rocket science. It's not impossible, but that's one thing that kind of goes away once you have a sensor, right? You don't need to worry if you go in one vehicle or the next. The sensor's there. It's always in the same place, and it's effective.
And there could be, I guess, a sensor malfunction, and you could replace that, right? Or
Oh yeah, and it'll, there's a diagnostic on it. So if it's not getting, just like, if you're losing signal from any of the other sensors, it'll report and tell you to go change it.
Well, yeah, I'm still pretty impressed that you guys already looked at our TFL truck toaster test and already made a couple of corrections in your software. That's really, really impressive. So thank you once again to you and your team. I'm still kind of set aback hearing this during this show. I want to so a couple of my perspectives from the toaster test, and then we can talk a little bit briefly about the iGauntlet, our a highway test. That's also high elevation. That's also very, very difficult. My impression of the engine is it's super smooth, right, and also pretty quiet, right? And I think, is that a characteristic of a kind of a straight six orientation as well?
It
Versus
is.
E6?
Yep. Yep. Inline six-cylinder engine is naturally balanced. So no matter if you're at idle or you're at heavy load, full speed, there's no shaking forces that develop as a result of that. And so they are, perfectly smooth. They feel good. They sound good. They're quiet, I should say. I know some people miss the rumble of the V8, but they are a very refined engine. And knowing that we were going to be going into, the product that you see behind me here, which is our Ram that you can get in a tungsten trim, right? Expectations there are it's smooth, it's quiet, it's comfortable. We also use it in our Grand Wagoneer, premium luxury vehicles. We needed to make sure that we were able to deliver that sense of quality and comfort that comes with this inline six-cylinder engine.
Yeah, I haven't driven, obviously, the no journalist or I think an owner has driven an RHO version, the off-road performance
Yeah.
truck version of this engine and its unique exhaust system yet either. So I'm really looking forward to that because I've driven the high output versions of this engine as well.
Mm-hmm.
I know we're focused on this kind of a standard output right now, a little bit in our discussion, but I cannot wait because I think at least me as an enthusiast of pickup trucks, an engine need to be not just smooth and powerful, which it is, but also kind of have another character, the sound quality to it, especially in a high performance application like an off-road truck, right? Like a specialty off-road truck. So I can't wait to see what your team has done there with the RHO. So that's still to come. And by the way, I want to tow with the RHO too. I'm not gonna let it off the hook.
Okay. Are you going to go up the same mountain, same twisty mountain?
I don't know. I think when I'm gonna get it because it's coming out within a month or two. Right now it's September, October, November. It's gonna be very quite cold, so
Oh.
I don't think we're gonna see the same toaster like temperatures. Uh, so I don't think I will take it on the same mountain run, but I think I'll take it on the Ike maybe, right?
Okay. Yeah.
We own the TRX, the Hellcat, and we actually, well, it was for a while it was our only pickup truck in our long-term fleet for a little while. So we pull trailers with it because we need to, right? Sometimes we are taking a side-by-side or a couple of motorcycles here and there or moving some stuff around. And a truck needs to do all kinds of stuff.
That's right. And that's what I said at the beginning is it's a more difficult case for us to design to because there's a broader range of applications and uses. But over the years, we've been able to try to, recognize those. The case of what you guys presented us here on the video is just another example where we take that feedback that we get and introduce it into our validation plan. So the new products that we have build upon the lessons that we've learned from the products that came before it.
Yeah, it makes total sense. And plus you also have, the benefit because you've seen different engine families in your career. So, I mean, you also have of course, the benefit of that. I want to talk a little bit about the Ike, right? So the Ike Gauntlet is a mountain test, as Roman and I talked about. And we've been running it for almost 12, 13 years now. And a part of it is not just, having enough power and capability, maybe to pass somebody on the way up the highway, but also the downhill performance, right? And now this trend in the industry, right? Everybody's moving away from very large displacement engines. And by everybody, I mean mostly, full-size half-ton, mid-size trucks and such, and SUVs are going to smaller displacement combustion engines. And having the back pressure or having the capability to help you slow down the mountain. Can you talk a little bit about that?
Yeah. So while the boosted engines have actually an advantage going up the mountain, right? Naturally aspirated engines, as you go up the mountain, the density of the air drops, their ability to produce power reduces because they're relying on the atmospheric pressure. Our turbocharged engines don't suffer from that, right? They're able to continue to use the turbochargers to compensate. And so we can make just as much power when you're at the top of the mountain as what they do at the bottom. And they have that advantage. And I was even wondering if you guys had ever thought about like introducing, as you go up in altitude on your test, an evaluation of the performance under like a passing maneuver or something. I think that might help illustrate the differences between naturally aspirated and boosted engines. But when you got to go back down the mountain, right? Unfortunately, the smaller engine just isn't able to pump as much air. Essentially, that's what you're doing is you're pumping air and using that to be able to produce the resistive force that the engine generates to help slow going down the mountain. So boosted engines that are downsized are always going to be at a disadvantage relative to the larger naturally aspirated engines, and they're not able to produce as much resistive force unless you do something like you've seen the diesels, right, where they add a Jake brake to the valves. But so far, I'm not aware of anybody that's gone to that measure with our gasoline engines.
And is it just a matter of the turbocharger design, right? Because let's say the Cummins, right? The big heavy duty Rams with the Cummins, they have the exhaust brake feature. Is that just of the turbocharger design itself?
No, it's mechanism in the valve train itself that's doing that and assisting. Okay. And so it's very intrusive, you might say, to the engine design, and certainly for the big diesel engines that spend a lot of time under these conditions, it's justified to go ahead and add that cost, add that complexity. But the smaller, let's say, gasoline engines, the use case for those, it's really hard to justify the additional devices and mechanisms to provide that.
So then it's up to like the entire powertrain, right? So, but your team or you personally, you're not kind of in charge of the transmission logic. Is that correct?
Yeah, and they kind of set the limit today for when we do the upshift, and there's maybe some reasons behind that. We'll take the feedback from the Ike, just as we did from the other test, and see if maybe there aren't some opportunities to modify that. But I really can't speak to it right now because I'm not part of the team that establishes those upshift points. But it's a fair question to raise, and we can go back and ask them.
Yeah, so we measure kind of brake application, as you know, going down the mountain. And in our view, and I know it's a little bit kind of rudimentary, is that the fewer times you touch the brake, the better the truck, the better the powertrain's capability to kind of slow you down.
Right.
But that's not to say that something dangerous happened, right?
No. And thankfully, there's brakes on the car too, so we can use those.
And there's also brakes on the trailer. Thank goodness.
Yeah, that's right.
So we always talk about safety. We always want to try to touch on safety. You're on the public highway, public road. There's people around you. There's people inside your vehicle and next to you. And setting up your trailer brake controller, and having the right gain and testing it and having the lights work, on and on and on. I do have a CDL, so and the fact that pre-trip inspections, tire pressure checks, right? The list can go on for a very long time. So I think safety is very important. You do have the brakes, but if you could take this message, I guess maybe to the transmission team as well, is that because you designed an engine that's so smooth and refined. Having a high RPM on that engine would not bother me personally as much as maybe another engine would, right?
Sure.
Because if you are downshifting and the engine is, let's say, near its top of its RPM range, and I'm talking about like 5,000, maybe 5,500 RPM, there's certain engines that that sound becomes unpleasant or annoying or worrisome, right?
Yeah,
If
right.
an engine is so smooth and quiet, maybe that RPM is not as worrisome, right?
Yeah. So there's potential to potentially raise it without, let's say, influencing or affecting the perception that the customer might have about the vehicle. So as I said, it's a fair question, and we can go back and ask.
Yeah, sounds good. I really appreciate it. So yeah, are you going to be at the RHO event jumping, or I don't know if you guys are jumping them. Do you want to jump trucks event?
I'd love to. We'll see if they invite me there. I try to, it's an opportunity for engineers to get out and meet with people like yourself to get the message out there. So I really, really appreciate when they give me the opportunity to do that. I hope that it happens this time, but they haven't asked me yet. So maybe you can put in a good word for me.
I will do that. I'll talk. I mean, we have really good contacts, not just with you, but also with your PR team. And of course, I want to thank your PR team for actually have us being able to talk like this. I mean, that's really important. You know, Rick and Nick Kappa and the rest of the team, Dale and the rest of the team. I really want to thank you guys for the time. You were very generous with your time. I really appreciate it. And I just want to close out with the statement about the engine that if I had any doubts before these couple tests, the toaster and the Ike, I don't have any doubts now as far as kind of the durability of the engine, because I know we're pushing them to the limit of maybe very like a millimeter over the limit, right? I know that we're pushing all of these engines very hard, but the fact that it just kind of says, give me some more, right? I'm ready.
Yeah.
I think it's really a positive thing.
Well, good. Yeah, I appreciate the feedback that you guys provide, and I really do love that you guys are actually testing stuff. Um, as a kid growing up, I used to read all the magazines to learn about hardware, engines and such, and I'll say it's drifted away from that. And I think anytime that people who are reviewing things, are getting into the details, doing tests, sharing that kind of information, it gives the younger generation an opportunity to learn. So I applaud you guys for doing that, and hope you continue to pursue that.
Yeah, and as soon as you guys have, you have a couple of electrified pickups coming on your way. So I can't wait, to put those to the test too. We're not going to go easy on them either.
Yeah.
So we're going to test all of them.
Sounds good.
All right, thank you, Alan. Really good to see you again, and hopefully we meet again in a few weeks and maybe jump a truck together.
Sounds good. Thanks, Andre.
Appreciate it.
Bye-bye.
Well, that was fascinating, Andre. I really am much wiser for it.
Yeah, and well, let us know what you think. Right? Is this a good trend? Are you guys convinced? Are you guys convinced that a turbocharged engine will be the best solution going forward, or do you want electricity? Do you want hybrids
Or extended range vehicles?
Yes,
That's another possibility. Obviously Ram has promised to come out with one of those.
Ram Charger.
So I had a thought, Andre.
Yeah.
All right. So mid-size trucks have gone from 6-cylinder to 4-cylinder turbos. Full-size trucks have gone from V8s to straight 6. What does that mean for the heavy-duty segment?
Now there are V8s and diesel V8s.
I know, but are we going to lose? Are we going to get smaller diesels? I mean, is the Cummins going to be, a 4-cylinder versus a straight 6? Is the Duramax going to downsize?
That's a great question.
I think the last truck in the variety of different trucks that we have will be the heavy-duty truck, because that is so specialized for doing a job.
Heavy work.
Right.
So do you want to hear my guess?
Yeah, I'd
Sort
love
of
that.
Educated guess. So we talked about Ford in 2011. They introduced the EcoBoost, right? But the EcoBoost has never made it to the Super Duty. It's been, what, 13 years?
That's a good point.
Right?
I never even thought of that.
So that EcoBoost has never made it to the Super Duty yet, if ever. So I think GM, Ford, and Ram, they're very careful about how they look at heavy-duty trucks. I'm seeing hybridization, maybe. So I'm seeing maybe big V8s with hybrid systems, electric systems in them. Or maybe, like you said, range-extended systems. That might make sense.
Well, I remember when we had the Godzilla in the F-250, right?
Yeah, yeah.
We thought that just by the name, it was going to be engineered for a lot of power. Instead, it was engineered for a lot of longevity, right? That 7.3 wasn't exactly the world's most powerful V8, even though it's a big displacement engine.
Well, it kind of had similar power to this.
I know, it's
Hurricane.
crazy. Yeah, I know.
Right.
Yeah.
And the Hurricane is 3 liters versus 7.3 liters in that Godzilla V8. So you're right. I think it is designed to last 200,000 miles or maybe 300,000 miles.
And what that means is you pull power, right? You want to not stress the engine, and by adding power, you're going to stress the engine. And the other thing that I kind of think has been evolutionary dead end, I fear, and for a while there back 4 or 5 years ago, I was so excited, was a supercharged V8, right? When the TRX came out with that supercharged Hemi, I was over the moon. And then, of course, when Ford followed with the Raptor R, same deal.
Yeah.
Wonderful. But now the TRX is gone. They're replacing it with the RHO, which will not be a supercharged V8. Ford keeps cranking out the Raptor R, but in very limited numbers. And Chevy is sticking with the 6.2, as far as we know.
Yeah, they do have the supercharged Cadillac.
They do.
The Escalade, but that's the only kind of push that they've made into that space.
So that may be an evolutionary dead end. And then now that we've got compact trucks, obviously those are the ones that are going to be, I think, electrified or hybridized or plug-in hybridized first, right? Ford has just revamped the Maverick, and now you can get it as a 4-wheel drive hybrid as opposed to just a normally aspirated hybrid. And the Escape that it's based on is a plug-in hybrid, so I don't think it would take Ford long to actually stick a plug on that thing. And hopefully Toyota will bring this out at some point.
And GM and Ram haven't announced anything in that compact space, in the tiny pickup space.
Yeah, and then, Andre and I were just talking about the Cybertruck, which we own, right? Mm-hmm. The conversation we were having, and I know you V8 guys hate to hear this, but I mean, don't shoot the messenger, it's the truth. For the longest time, the competition in full-size trucks was kind of right around the corners, right? Like, hey, Ford came out with a tailgate that had a step in it.
So we're going to have a barn door tailgate.
Then, the Ram came out with a barn door.
Or a folding tailgate.
Right? I mean, this is not exactly, evolution, and certainly not revolution.
Revolution, yeah.
But then, electric trucks come along, and the Cybertruck not only completely redefines the form, but let's talk about the innovation that it brought to the world of trucking. First and foremost, air suspension.
Ram's been doing air,
right?
for some time.
But Ram's been doing it basically as a helper when you're towing, right? So when the truck starts to squat, you can raise it, or you could raise it a little bit. On the Cybertruck, you can raise that thing 16 inches. I mean, it's basically...
Or up to 16.
It's basically an off-road tool. Then they outdid everybody else, and they went 4-wheel steering.
And steer-by-wire.
And first ever steer-by-wire.
Yeah.
Which makes that truck incredibly maneuverable and makes it much easier to park. And then, of course, Ford did aluminum, but these guys said, hold my beer.
How about stainless steel?
Let's look at what the DeLorean did, and we're going to do stainless steel. And then, if you're in the electric world, right, for the longest time, the architecture, how many amps was it? It was...
Well, it's been 12 volts, right?
12 volts,
Model T was 6 volts.
Yeah, and then it went to 12.
12. There's some hybrids with 48 volts. Certain components are 48 volts.
But it's hard to do everything because you basically have to redesign every component. So you have a headlight work on a 48 system.
Or an LED light inside of your cab.
And you're maybe
something.
wondering, why do you want a 48 volt? Because it uses less wire. It's more reliable. It's just a lot more robust architecture, and it's a lot lighter architecture. So it's a pretty big step. And then,
And Tesla did it.
Tesla did it, yeah. And, Ford could have done it a long time ago, but they didn't. And then, there's even more innovation when you talk about, full self-driving, which is coming, which probably isn't as good as Blue Cruise.
Well, and efficiencies, right? Efficiencies like heat pumps and different designs, that have to do with that.
Yeah. So if there was one vehicle this year that brought the innovation, and I know a lot of you out there hate the look of it, I completely understand that.
Which is fine, yeah.
Which is fine.
Yeah.
What I would say is you can drive around the world and not see anything like it, and you might be saying that there's a reason for that because it's ugly. But it's hard to be different. I mean, look at the mid-size crossover segment and look at the full-size truck segment. They pretty much all look alike. You know, I mean,
It's hard to find a standout.
Yeah.
Yeah.
I mean, okay, so Ram's got a big Ram, Ford's got the big Ford, but the form factor is pretty much the same. And if you saw them coming down the road and they were far enough away, I couldn't tell them apart. But yet the Cybertruck, definitely. So, a lot of innovation there as well. Where was I going with this, Andre? Do you know where I was going with this?
Well, I think you're going to say, we welcome innovation. Ram and Ford and GM need to break ground. And I think Ram is trying it with the Ram Charger, right? I mean, they're going to have a range extended hybrid.
It's a hard thing to do because if there's any one buyer that is the most conservative in their, and I don't mean conservative politically, I just mean they don't like change. It's the truck buyer, right? The truck buyer is, my daddy drove a Ford, and gosh darn it, I'm going to drive a Ford
With a V8.
with a V8, right?
Yes, exactly.
Yeah, because and that's the way it is, and that's the way it's always been. So it's very hard to change people's perceptions when it comes to trucks, and yet I think with Tesla going out there and kind of setting the bar way up, way out there, I think it's going to force both Ford, GM, and Ram to actually innovate.
And maybe Toyota, and also Toyota.
Yeah, besides just putting I'm going to do a barn door.
Or a side step.
Or a side step,
Yeah.
or some other, kind of silliness. Well, we're going to put a can opener in our tailgate. Great. Wahoo. You just basically, you created the truck that was in the commercial. Right?
That thing got a Hemi?
Yeah. So shall we show the other commercial?
Sure.
That thing got a Hemi commercial?
They did so many.
Yeah.
They did so many.
Let's-
Another Hemi commercial.
Let's show the other one, and let's leave it at that because I love these commercials, and my heart aches for the good old days of Hemis and Coyotes and
But they're not over. Those days are not over yet.
but the simple simple days are over.
Simple times.
Yeah, I mean, if you want a simple truck, get yourself a square body Chevy.
Bam. With a V8.
Yeah, maybe
So,
a tall boy
If you still want the
250.
V8,
Yeah.
and if you want an overbuilt truck for your purposes,
Yes.
you could still look at the heavy duty.
Yes.
Even a work truck, maybe. You could still look at the GM light duty because Silverado Sierra 1500s, they have V8s everywhere. That's one of their main engines. Ford offers a 5-liter still.
Or if
So-
you really love watching those country music videos, get yourself a tall boy.
There you go. And with your big boy.
And a square body Chevy, which we've owned, by the way.
and your high boy.
Is it high boy or tall boy?
It's a high boy Ford.
Oh, I thought it was a tall boy. It's a high
Tall
boy.
boy is probably a beer, like a tall
So
beer.
get yourself a tall boy for your high boy Ford. And I gotta say, when we owned Big Green, I love that square body Chevy.
Yeah.
That was so much fun. So much fun.
Yes.
Yeah. And I can see why people are nostalgic for those days without seatbelts, without airbags, the stuff that real men drove. All right, guys, let's go on the That Thing's Got a Hemi commercial, and we'll see you next time. Ciao.
Thanks.